Hi everybody, how are you doing? I'm once again here to teach you something about matrices, and this is now our last lesson in matrices. Today we're gonna talk about solving simultaneous equations by the matrix method. At this stage, I believe you have dealt with the simultaneous equations before. You have talked about solving simultaneous equations by substitution. You also talked about solving simultaneous equations by elimination. Okay, so what do we call simultaneous equations? We are always given a pair of equations with the two unknown variables. In most cases, we use x and y, but we can use a and b. Okay, so how do we make use of the matrix method to solve simultaneous equations? This is the fact that we're gonna use. If you get a matrix A and multiply it by A, okay, you get the inverse of a matrix and multiply it by the matrix. We say that this gives us an identity matrix. Okay, so this is the fact we are going to exploit today to solve simultaneous equations. So let's look at this equation. So this is the equation. They are saying that okay, they require us to find the inverse of the matrix C, which is 5, 3, 2, 2. Okay, and after finding the inverse of that matrix, they want us to go ahead and solve the pair of simultaneous equations. So we learned in our most recent lesson, that was lesson 4, that to get the inverse of the matrix, you need the determinant of that matrix and then the adjoint of the matrix. So let's do it. So to make our life simple, let us call the inverse given to us A. 5, 3, 2, 2. Okay. Now, the task we have is to find the inverse of this matrix. We know that this is going to be 1 over determinant of A times the adjoint. Okay. And how do we get the adjoint of the matrix? We say that to find the adjoint of a matrix, okay, what you do, you are going to interchange the elements on the principal diagonal, and then the elements on the secondary diagonal, you change their signs. Okay, so let's go ahead. How do we get the determinant of matrix A? Okay, this is going to be 1 over, look what the matrix we have here. This is the principal diagonal. We say the product of the principal diagonal, which is now 5, times 2 minus 2 times 3, okay? Then that's the determinant, okay? The adjoint is you have the elements on the major diagonal, the principal diagonal, changing their positions, and then these elements just change the signs, okay? So what do we get? We are ending up with this is a 10 minus 6 is a 4, okay? Then this is a 2 minus 3 and minus 2 and a 5, okay? So what do you end up with? You can scalar multiply through, and you will end up with 2 over 4 minus 3 over 4 minus 2 over 4 and then 5 over 4, and that will be the inverse of the matrix we have just called A. Okay, now to find the solution to the simultaneous equation is given to us, what we do, we write, let me write the equation 5x plus 3y equals to 7. Then 2x plus 2y equals to 2. So in the matrix form, this can be written as write the coefficients, extract the coefficients. A coefficient is that number which multiplies with the variable. So here it is 5 times x, I write a 5, then 3 times y, I write a 3, 2 times x, which is a 2, then 2 times y is a 2, okay? multiplied by xy will give us 7, 2. So how do we move from this step using the inverse we have just computed to come up with the solution of this equation? This is simple. So after writing the matrix of coefficients, what you realize is the 5, 3, 2, 2 is the matrix A, okay? And we have the inverse. So I know that if I get A and multiply by the inverse, okay, it will give me an identity matrix. Okay, in this case, since it's 2 by 2, this identity matrix is going to be 1, 0, 0, 1. We only have 1s on the major diagonal. So this is what we should use here. Okay, look, we have 5, 3, 2, 2. That's the matrix A, and it is multiplying by xy to give us 7 and here 2. Okay, so what I need to do is something very simple. Let me put here the inverse, okay, of this matrix. Also, what I do this side, I also have to read the other side. So what is the inverse we computed? This was 2 over 4. This was a minus 3 over 4. This is a minus 2 over 4. And this is a 5 over 4. So same thing happened the other side, 2 over 4, minus 3 over 4, minus 2 over 4, and then 5 over 4. Okay, so we let's multiply. I'm assuring you this is going to produce an identity matrix. Let's see. Remember, to multiply matrices, we multiply row by column. Okay, so what does it mean? I get my first row and multiply by the first column here. So I have 2 over 4 times 5. That's 10 over 4. Okay, plus, but this is now a minus 3 over 4. So minus 3 over 4 times 2 is minus 6 over 4. Okay, then here I have 2 over 4 times 3. 2 times 3, what do you get? Okay, 2 times 3, we get a 6 over 4. Okay, minus 6 over 4. Then down here, we got the down arrow. Okay, this row, minus 2 over 4 times, that is a minus 10 over 4. Okay, then 5 over 4 times 2 is plus 10 over 4. Then we have minus 2 and the 3, that is minus 6 over 4. Then a 5 will be 10 over 4. Okay, into x, y equals, so let's do the other side. Okay, 2 times 7 is 14. Okay, so here I have 14 over 4 minus a 6 over 4. Okay, then down now it is negative 14 over 4 plus 10 over 4. We are done multiplying that side. So what do we see here? 10 minus 6 is a 4. 4 over 4 is 1. So this is 1, this is 0, this is 0, and this is 1. Okay, into x, y is equal to the other side. What do we have? Okay, and a negative 14 minus a 6. What do you get? That's 8. 8 over 4 is a 2. Then down I have 10 and negative 14, that is 4. So this is a negative 1. Now from what we have, okay, we say that if you multiply any identity matrix by any matrix, it will never change. So this will be x, y, okay, is equal to 2, negative 1. And these are matrices of the same order. It's a 2 by 1 on both sides. So it will mean that x is equal to 2, y equals negative 1. Okay, and we have solved the simultaneous equation by matrix method. All right, so what is important here? Let us see, highlight the most important step in the next example so you understand more. So this question says solve we have this question. It says solve the following pairs of simultaneous equations using matrix method. So we have been given 3 pairs of simultaneous equations. Okay, I will solve for you the last one because I want to give you a caution here. Okay, when you look what the equation is given, okay, the first is 3x minus 4y is equal to 7. And then the second equation begins with 6y. Now, if you are to solve a simultaneous equation by matrix method, you make sure that the same variable starts in all equations, okay? The starting variable in the first equation is 3x, okay? So the starting variable in the second equation must also be an x variable. So this is 4x, okay? Minus 4y equals to 7, okay? Plus 6y is equal to 15. So sometimes examiners, try to give you this to confuse you. Since you're a student, sometimes you are in a hurry trying to answer questions, you'll forget to rearrange these variables such that they are matching and end up, misfiring. So this is just it is given to you to ensure that you take a caution before answering questions. Okay, that's what I wanted to caution you about, and it's so important. It's quite often you are going to find equations where they have been mixed up. The order is not consistent. What is in the first equation is x starting, and then the second equation is y starting. Okay, so make sure you arrange equations so that they start with the same variable before you attempt to answer. So let's answer this. So what we do first is to arrange this equation is so the variable matches. We have done that. Next is to extract a matrix of coefficients. So you extract the coefficients and write the matrix of those coefficients. In this case, I will have a 3. Okay, then this is a 4. Then this is a minus 4 and a 6. Okay, this multiplies by x and y. That's the order because x, the starting variable, equals to 7 and 15. Okay, the next step is to now get the inverse of this matrix. Okay, so let's get the inverse of 3 minus 4, 4 and the 6. How do we find the inverse of a matrix? We need the determinant. Okay, we need the determinant of the matrix, and in this case we are going to have 3, but 3 minus 4, 4, 6 inverse equals to, okay, what the determinant, 1 over determinant, multiply the elements on the principal diagonal. That is going to be 3 by 6, which is 18, minus the product of those on the secondary diagonal. That is a negative, it is a 4 times negative 4, that's negative 16. Okay, then interchange, we are going to have here 6 taking the portion of 3 and then 3 switching with, so this is a positive 4, and then this is a negative 4 because the elements on the secondary diagonal change signs just. Okay, so if we are done with the inverse, okay, 18 minus a 16, that is a 34, right? Is a 34. So I have 1 over 34 into a 6, 4, negative 4, 3. Okay, now multiply by the matrix, which is a 3, negative 4, 4, 6 times x, y gives us, okay, 1 over 34 into 6, 4 minus 4, 3 into 7, 15. Okay, I'm assuring you this side will always produce an identity matrix. As long as you have committed the inverse so well, okay, we shall always get the identity matrix. So 6 times 3, let me write this 6 so well so you can understand that what I have here is a 6. 6 times 3 is 18. Remember, row by column, okay? 18 plus a 4. 18 plus a 16 is 34. So here I have 34. And remember, I have 1 over 34 down here. So that will multiply to give it a 1. And then 6 by a negative 4 is negative 24. So this is a 0, this is a 0, and this will be a 34. If you want, you can try. It is a 4 and a 4, okay? And then, which is a 34 into x, y equals to, okay, let's multiply here. 6 by 7 is 42. And the 4 by 15 is 60. So that's 102. 02, okay? Then down, negative 4 by, that's negative 28, okay? Negative 28 plus 45. So down you have 45 minus 28 is 17, okay? And there is a 34, 1 over 34 down here, okay? So what do we get? Remember, if I multiply here, okay, I can multiply this side by 1 over 34, it will be 11001. So we care so much about this side, okay? What you have to do is get 102 divided by 34, okay? But I think that is a 3, okay? Because it by 4 is 12, 3 by 3 is 9, so that is 90, okay? 102. And then 17 is a half, okay? So I can easily tell x is 3, y is a half. Very fast. So if you go ahead and multiply, you discover x is equal to 3, y is equal to a half. So we have solved simultaneous equations by the matrix method. So what is the most important step I wanted us to highlight? It is the inverse of a matrix, assuming you have a matrix A, and you get the inverse of that matrix and multiply it by that very matrix. Then you end up with an identity matrix, okay? For 2 by 2, it is going to be 1001. So that's the most important step that solves simultaneous equations, okay? Some people can try to solve without using the inverse, and they use the adjoint. It also works out, but in the end, you have to divide to have the value of x and y. So if you can use the inverse, the better, okay? Maybe, let me just look at this, which is 2x plus 3y is equal to 7, and the x plus 2y equals to 3. So here, if we extract the coefficients, we have 2, 3, 1, and 2, because the variables are arranged in order. We have x starting in both equations, and y is following it, so the variables are matching. This is x, y, okay, is equal to 7, 3. Now, what we need most is the inverse of this matrix. It should multiply on both sides. So if you multiply the inverse of this matrix on both sides, it will create an identity on the left-hand side, an identity matrix. And then you just multiply the right-hand side. Oh, look what the one I'm writing this. I'm writing it as a fraction, but this is not. This is matrix. Sometimes it is a common mistake. People forget and write matrices as fractions, but you have to be just careful. This is 7, 3. Okay, so let's go ahead. Only the inverse of this, and the inverse is 1 over determinant times the adjoint. Remember, adjoint, these elements switch positions, and then these just change sign. Okay, so let's work out this and try to get done. Okay, let's write the inverse and multiply it on both sides. So here the inverse, I will have 1 over determinant, 1 over, this is a 4 minus 3. That's now calculating determinant. The product of 2 and 2 is 4. Then 1 and 3 is 3. Then write the adjoint. Okay, here. The adjoint, these two will change, but they are the same, so you don't really realize that they have changed. Then this is a minus 3 and minus 1. Okay, write the same thing even the other side. 1 over 4 minus 3. So adjoint is a 2, negative 3, then negative 1 and a 2. Okay, so let's multiply. 4 minus 3 is a 1, so we just multiply here and end up with the 1 0 0 1. Okay, you try to multiply out 2 times 2 is a 4. Okay, minus 3 times 1 is now a 1. So x y is equal to, okay, 2 times 7 is 14 minus 9. Okay, then 1 times negative 1 times 7 is negative 7 plus a 6. Okay, because 1 over 4 minus 3 is a 1. And if we do the math and subtract, this is going to be 5. And down we have a negative 1. Okay, so from here we just read off that therefore x equals to 5, y is equal to negative 1. So solving simultaneous equations by matrix method is very simple. Okay, but this is a caution to all of you. If you are to solve simultaneous equations by matrix method, the degree of the variables must be the same. Okay, what do we mean by degree of the variables? Let me give you here an equation. If I have an equation like a 3y squared plus x equals to 4, then I have x plus y is equal to 7. I cannot solve this by matrix method because this is degree 2. Okay, y is powered 2, and yet here in this other equation there is no y squared. Never attempt to solve such simultaneous equation by matrix method. You will fail. This is better solved by substitution, not even elimination. Okay, so the variables must have the same degree. Okay, sometimes you are tricked. Someone can write 3x equals to 4y plus 3, and then x minus y is equal to 8, and they want you to solve. Just bring this y here, okay, so that you have the variables, the unknown is on the left hand side, and then the other side you have constants. Then you can form a matrix of coefficients, find the inverse, multiply both sides by the inverse, then write the value of x and value of y just straight away. So it is really very simple. Okay, and I think I've given only one question here, but you can try it out. This has been a very short lesson. Okay, I wish you the best, and this is the end of matrices. Now what I'm going to do, let me write down so many questions about matrices, try to solve a variety so I give you, enough exposure. Then you can go in the world and solve questions on your own. And this is very important to you students. The education system today, because of the coming of, the privatization of education, many people are taking education as a business. And what they are doing today, they struggle to ensure that learners go home with very nice grades. But having nice grades may not necessarily imply that you have learned. Okay, so try to desist from situations where you are depending on a person solving for you problems all the time. That's not good. Okay, what is good is learning a principle in mathematics, like I know that if I get the matrix and multiply by its inverse, end up with the identity. Then you apply this in given situations. Apply this in given situations. Okay, and using your personal creativity. The personal creativity is what the examination is looking for. Using existing knowledge to solve a problem, okay, is what we are looking for. And the person who does that is a bright student, and that is the person we are looking for to take in the military, to become a doctor, to become an engineer, other than walking out of schools with very nice grades. But when you are now, you are just representing somebody's work. That is not good. I'm cautioning you. It is happening. I know it. Okay, so I'm cautioning you serious about that. Make sure whatever you do, you are yourself. Learn, practice a lot. You become perfect, and now you become independent, and you are able to write down the exam so well without any kind of fear. Fear is what makes so many students fail. All right. Yeah, sometimes it is not really so good for teachers to go to class and deliver content without cautioning you about what happens in the world. But the world of work demands that you have to be authentic in whatever you do.